How to search for chemical information on the Syntelly platform. The search interface is the first page that the user sees by default. Today, search by structures and search by literature are possible. Search by reactions will be available soon. Find molecules using the search bar or by drawing a structure in a graphics editor. Systematic names, such as the IUPAC name, various ciphers, and the formula of a compound in SMILES format can be entered in the search bar. Enter the trivial name of the compound in the search bar, for example, tideglucib. Please note that only Latin characters, numbers, and special characters can be entered into the search bar. One connection was found in the database that fully matches this name. On the left side of the screen, a panel with settings appears. The search can now be repeated, extending the range of connections output. Select the substructural search and click the Apply Filters button. You can also press the Enter key in the search bar. The request was converted to SMILES format, and the search results include those molecules for which the original request is an exact substructure. In other words, substituted derivatives of tideglucib. Let's switch to a chemical similarity search and find structures that have high similarity to tideglucib, that is, those compounds that can be called its analogues. Let's set the lower similarity threshold at 75% and run the search. The results are predominantly substituted thiodolazine diones, meaning they belong to the same chemical class as the parent tideglucib. For each search result, the structure number in Syntelly database is available, possibly to edit the structure in Molecular Editor for further search. Quick viewing of the description, possibility to add to dataset, as well as copying SMILES or downloading MOL file, copying the hyperlink to the description and downloading the structure picture in PNG format. To select several connections, press the Control key. If the connection properties have already been calculated, at the bottom of the screen there will be different colors if not grey. For each connection, you can go to Search by Literature or Search by Reactions. Let's go back to tideglucib and do a search by literature. The platform automatically transfers the structure to the search bar in the form of SMILES, while you can search manually by name. A list of literary sources appears, primarily patents devoted to this compound. The structure in the patients are already recognized by Syntelly methods. When opening a patent description, its abstract is available. It is possible to copy the number and study the structures in detail. For example, there are 4 compounds in this patent, including the searched tideglucib. It is possible to apply filters to the search, for example to search only in articles and only in Russian, English or German. Let's display the results of the article search. In the article description you can see the title, DOI reference, abstract, authors and publisher. Let's take a closer look at the structure description. It contains an overview of all available information about the compound. The structural formula of the compound is on the left. Below it are buttons that allow you to copy the hyperlink to the molecule description. Open the molecule in the editor, add it to the dataset, and save the picture in PNG format or the full description with all information in PDF or MOL format. Also, you can run Search by Literature or Search by Reactions here. The right side of the description contains connection information. The structural section contains various forms of the structure record, SMILES, initial and initial key, the name according to the IUPAC nomenclature, generated by the Syntelly neural network, as well as the gross formula and molecular weight. The synonyms section contains various names and ciphers under which the connection appears in the literature and databases. The Bio section provides information on the biological activity spectrum of the compound calculated using platform models. For each model, an assessment of prediction reliability is provided based on an analysis of the model applicability area. The prediction of cytochrome inhibition is fairly reliable, but the Syntelly models are less certain about other types of biological activity. The next block provides information on the physicochemical properties of the compound. For melting point, experimental data are available here, as evidenced by the bright green label EXP. In some cases, sources are indicated for experimental data. In the Toxicity tab, the toxicity spectrum of the compound is predicted. Some models, such as the model for LD50 on mice when taken orally, demonstrate a fairly high confidence in the prediction, while the intravenous LD50 model for cats gives a less reliable prediction. And in the case of the reproductive toxicity model, the structure of the compound is beyond the scope of the model. Transparent presentation of information about the scope of applicability of prediction models is one of the key advantages of Syntelly, allowing the user to make informed decisions about the future use of prediction. In addition, the description contains information on environmental toxicity, the complexity of the synthesis of the compound, as well as standard drug similarity indices, Lipinski's rule of 5, Gauss filter, Oprea's rule, Weber's law, QED drug similarity index, and compliance with the Payne's non-specific activity filter. The last section of the description contains hyperlinks to external databases from which you can get additional information. If there is no connection of interest in the Syntelly database, you can obtain property prediction results using the molecular editor. To draw the structure, open a separate tab in the left menu. The molecular editor allows you to find the desired connection by name or smiles, and in addition provides the ability to draw the connection manually. Let's continue with the same tideglusib. Enter its name in the search bar and select the drop-down result. The structure of tideglusib appeared in the edit window. Change the structure of the compound by adding a trifluoromethyl group. By the Calculate button, an analog connection description appears, providing the entire range of information. This way, you can get predictions for your own connections that are not in the platform's database. This completes our introduction to the types of chemical information retrieval on the Syntelly platform. See you next time!